All right, 2.3, rates of change. We're going to talk about some notations and some interpretations. There are several notations that we're going to look at. It doesn't matter to me specifically which one you use, but you need to be able to look at them and interpret them and know what they are if they're used by someone else. Make sense? I'm going to take your silence for a yes. Makes perfect sense. Of course, Dr. Hanson, I know exactly what you're talking about. All right, so there are 5 phrases that you're going to fill in that mean the same thing. The first phrase is the slope of a curve at a point. And that's what we did in the last section. We were finding the slope of the curve at point P, or whatever point they gave us. Slope of the curve at the point. Okay. The second one, instantaneous rate of change. We saw that last time too. Last section, instantaneous rate of change. Means the same thing. The third one, slope of a tangent line. We already mentioned that one. It's the same thing. Slope of the tangent line, instantaneous rate of change, slope of a curve at a point. So if a question asks you for any one of these, you could interchange it with the other phrase that makes you feel a little bit more warm and fuzzy, and you'd be okay with it, right? Yeah. The fourth one, this one we haven't talked about. This is the limit of slopes of secant lines. Our book does not heavily concentrate in this. We will see it mentioned, I think, in one other section. We'll kind of talk more about it there. But it is an interchangeable phrase. So I'm mentioning it for the sake of mentioning it, and that's really about it, okay? We're not going to use it too much. There's one more, and the one more here is the one that some of you have seen before, derivative. And very soon, it's the one that we will use the most, derivative. All of these mean the same thing, okay? All of them. So these are the meanings, and the next thing I want to show you, I think if I'm remembering right, is the notations. Okay. There are several notations for derivative, slope of tangent line, IROC, and so forth. One notation you've already seen me use uses a prime. Kind of looks like an apostrophe. It's usually a little more straight up and down than that, but it's f prime of a. Okay. Another notation looks like this, dy dx. And that's kind of how we say it shorthand, f prime of a, dy dx. It's not really effective or appropriate to say that, but we shorthand it because that's what we do, right? We like to shorthand things, okay? And then the third one is the one that is used the least, but I'll mention it, d dx of f of x. The first one's really friendly because it looks a lot like the f of x notation we already use, right? So in terms of notation, writing them down, it's very friendly. The second one is very friendly in terms of remembering its slope. I'm calculating y's over x's when I'm calculating this. So it has a very natural tendency inside of it. And then the third one kind of combines those two notations together. This is telling you that it's the slope of the f of x function. Okay? The first two are used quite a bit. We'll probably use the first one the most. And then the last one is definitely used the least. Okay? This is my second page, isn't it? All right. Oh, it bleeds over. Okay. Okay, so we're going to have a function. It's going to be called capital B of t, and it's the balance in dollars in a mutual fund, t years after an initial investment. So the first question asked is, what are the units on dB dt? Now, this is the friendliest way to ask the question because it's written in the fractional slope notation, so that's actually very friendly. What are the units on B? Dollars. What are the units on T? Years. So what are the units on dB dt? Dollars per year. Okay. Now, part B is not something that we should have to really do a whole lot with anymore because you know how to do it. We've been doing this for a month now. Okay? it says that we're going to interpret what does B of 3 equals 792 mean. And you did something like this on the test for me last week. So what would I write down for B of 3 equals 792? Okay, so 3 years after the initial investment, the balance in a mutual fund, right? Is 792, and of course you want to put the dollar unit on there, right? So you guys did great on this on your test, no problems at all. C is like what we did in the last section, B prime. It's how something's changing, right? Now, it's still 3 inside. That didn't change, which means the statement will start out the same way. It will say 3 years after the initial investment. That's the when. So, 3 years after the initial investment, what? Yeah, it's still the balance in the mutual fund, right? So the balance in a mutual fund okay, so that's the what, and then the when, or not the how, I'm sorry, you said is increasing. So how do you know it is increasing? Okay, it's positive. And why do we say is increasing? Because it's a specific point in time, not over an interval. So it is increasing, and then by how much? 5.6, close, not percent, dollars per year, because we didn't do it for a percentage change yet. We're doing it for, on this one, a instantaneous rate of change. So it's output per input. Dollars, whoops, let me get my per year on there. Dollars per year. Okay. This one says interpret dB dt equals negative 4.7 when t equals 5.1. So it looks really complicated, it looks kind of messy, right? But all the notation is there, it's just formulated slightly different than the last problem. The last problem had the input inside the parentheses. This one has the input outside at the end, t equals this. Okay? So the t equals this is the when that we start with. So how will I start? What's the when? 5.1 years. So 5.1 years after the initial investment. What? Not yet. First what? Not how. The balance in a mutual fund. Okay, present tense is, this time it's decreasing because it's negative. So this is decreasing by how much? $4.7 per year. And then E, again, same interpretation process, right? What's the when on E? Okay, 4 years after the initial investment. The balance in the mutual fund, that's my what. how? Is increasing by 16 cents, $0.16, right? Per year. And I've used this phrase, but I wanted it in black and white on your paper. Units for the derivative are the same as the rate of change for slope. Outputs, units per input units. It's always output per input.